to the first question on this practice set. This is going to involve a bunch of different equations. Just to kind of outline them, we've got power equals current times voltage, and voltage equals current times resistance. We dealt with those in way in the beginning of the year. There's a new equation, intensity is power over surface area. For a sphere, right, surface area is pi r squared, but surface area for a rectangle is, pi is just length times width, so we'll be using both. We also will be using efficiency. So let's see what this looks like. When we start our problem solving, as always, we draw a label diagram. So a 200 watt light shines from 30 centimeters away on a solar panel of 17% efficiency. If the solar panel is 3 centimeters by 15 centimeters, how much current will run through the 10 ohm bulb? So to start drawing this, here's my light source. Power of the light source is 200 watts. It shines down here. The distance between here and my solar panel is 30 centimeters. Here's my solar panel, right? And that's hooked up to a light bulb. And we know that this light bulb has a resistance of 10 ohms. We know that the efficiency of the solar panel is given as 17%. We know that the surface area of the solar panel is going to be 3 centimeters by 15 centimeters, which is, let's check. 3 times 0.15 is 0.0045 meters squared. So I converted those 0.03 times 0.15. And then we can start then we can start this. That's all the given information. So I'm going to start. You can start anywhere, but to me, the place to start is efficiency, because it's going to help me figure out what I need. So here's my efficiency equation. I know that this is 0.17, and I don't know power out or power in yet. Some people make the mistake of using the power of the light source as the power in. It's not. And let me explain why, because this is really important. The power from the light source is coming down and hitting the solar panel, but also hits all of this too, right? It makes this it illuminates a big wide area. How much of it is actually hitting, and with what intensity is it just hitting the solar panel? So we need to find that out. So that's what we're going to do first. So we're going to use the intensity is going to be power of the light source and the surface area from that light source, right? So which is going to be 4 pi r squared. So that's 200 watts divided by 4 pi and then 0.3 squared, because that's the distance. So we can calculate that. And it's going to be 176.8 watts per meter squared. Now, we can take this intensity, this is the intensity at the solar panel, at that location. So now we're going to rearrange this equation just a little bit. We're going to do power into the solar panel is going to be the intensity that it receives times the surface area of the solar panel. So to do that, I'm going to take 176.8, but now we have to use the area of the solar panel. So that's 0.7956 watts. Great, so that's power in. So let's number these steps. So this is really step 1, this was step 2, and now we're using this as step 3. Step 4, now we need, I didn't finish step 3 yet. So now we're going to be able to solve for power out. So we're going to do 0.1, this is 17%. So 17 divided by 100 is 0.17. And then multiply that by 0.7956. So you get power out is 0.135 watts is power out. Now we can use this to help us find the current, So let me use a different color so it's easier to find, because I'm going to have to do a little squishing here. We know that power is I times V, and we know that V equals IR. So if we substitute this in for V, we get P equals I squared times R. So I times R is I squared. So if this is 0.135, and we know that R is 10, then we get 0.135 divided by 10, which is 0.0135, and take the square root of that to get the current. So I ends up being 0.116 amps. And that's the answer to this question. So you can see this pulls a lot of stuff in. You're going to do that for the rest of these problems. Some of them will be in a different order. You might not have resistance. You might have current and voltage already, where you don't need to substitute in Ohm's law. You may have the intensity, so you may not have to calculate this intensity before you do this step. So sometimes you won't have to do all these steps. So try them on your own and see how that goes.